So good morning. This is Dave McAllister with Scalyr. Welcome to our continuing Insight series. Here is this webinar. Today, our topic is on the Dev's Guide to Containers as a Service. And joining me today is Sylvia Fronczak, who's a software engineer, has been in this business quite a while. And today, Sylvia is going to cover the basics of containers as a service, as well as looking at a little at the CaaS providers. Key concepts that are really important for you to understand, and then how to get started with a demo in the middle of this. With that, Sylvia, thanks for joining the webinar. Hopefully the weather's not too bad where you are out in the Midwest, and take it away. Hopefully you're unmuted.
All right, yep, I'm finally unmuted.
Sorry, operator error.
That's all right. No, I muted myself and it didn't let me re-unmute myself. Okay, great. Thanks for having me join here. As Dave mentioned, my name is Sylvia Fronczak. I've been a software developer for about 18 years now. And the last 5 of those have been working in both like container as a service and platform as a service environments. So one of the things I wanted to start with is kind of part of the as a service evolution. We're not going to look at every possible as a service option, but kind of focus on 3 of them. I think it just gives you a better understanding of why we use containers as a service and what problems it's solved over time. So first, we came in probably around 2006 or so with infrastructure as a service, where we wanted to abstract away the physical hardware we needed to run applications. And this was great because it just let companies rely less on the on-premises hardware to run their applications infrastructure, and they were able to focus more on the application environment. So after that, we brought in platform as a service. So platform as a service provided a lot more support and added in application environments for developers. So we were able to stop worrying about our operating system, our networks, and other technical issues that we didn't really want to worry about, and it let us focus more on just our applications. And all of that was awesome, but not quite good enough, of course. So now we have containers as a service. And with containers as a service, it kind of gave us a little bit more flexibility than the platform as a service providers gave us. And we're going to go a little bit into that in just another slide. So this is just a little high-level view of what infrastructure as a service gave us. So as you can see here, the virtualization, the servers, the storage, and networking. And then all the things in the white on the graph are the things that we were still responsible for. And then containers as a service, which is kind of the middle ground, also gave us container orchestration, took care of the VMs for us, and the operating system, as well as letting us just focus on the application and the runtime, which in this case, we want to put our runtimes in containers. And then platform as a service really takes care of everything except the application. So this is really a more rigid application development platform, just because it sometimes limits you to certain languages, certain build packs, things like that. But it is a good starting point for a lot of companies. All right, so this is just kind of showing the 3 side by side, kind of what they provide and what they give you. And then let's take a look at containers a little bit closer here. So as I mentioned, we don't have to worry about the operating system or the virtual machine when we have containers. The container engine is provided by whoever our CaaS provider is, and then we worry just really about the containers, which contain our applications and our any libraries that our applications require. So the benefits of this is that it just isolates the applications within the container. We can run it on just one operating system, and it does let us run it most anywhere. It does still require, the example we're going to use today is we're going to do a little demo using Docker, and we're still going to need, Docker itself is still going to need a Linux VM, which if you install it on your Windows machine or your Mac, it's going to bring that along with you. We'll see a little bit of that later. And kind of looking further at the containers versus VMs. So as we saw, containers kind of share an operating system. While if we had deployed our applications just to VMs, we could put multiple applications on one VM, but then we wouldn't be able to scale them independently very well. So if we have a virtual machine, we have to have an operating system on it. Containers just share the operating system of the virtual machine that they live on. So it's a lot lighter weight, it starts up a lot faster, and is really good for microservices, small processes, small jobs. But there is still a place for VMs where we have like more intensive application, we need more control of things in different ways. So there's still a place for them in the world. So next, why do we want to use containers? So one of the things, I think a lot of people have heard of the 12-factor app, where we want to have immutable deployments and repeatable deployments. Portable containers give that to us as part of the package. The other thing that we mentioned before is that it really has like fast deployment and start time. So the other thing that CaaS providers give us, they help us orchestrate our containers through container orchestration. So what this means is that they'll help us with our resource management, our lifecycle management, and our service registry and discovery. So with lifecycle management, as we'll kind of see this in a little bit in the demo, but it can help bring up extra pods if we need them, or extra containers containing our applications if we need more resources or more containers. I lost my words there. And the other thing it provides is like the ability to load balance and scale and monitor all our containers. And then the container infrastructure that's kind of like higher up is actually going to give us all the network and storage management solutions that we'll need. Okay, and then most of the time we're actually going to be playing a little bit with Docker. So Docker is a really nice container engine. There's obviously a lot more. There's LXD, OpenVZ. But one of the cool things about Docker is that they also provide a lot of Kubernetes integration at this point. So let me escape out of here and take you to a little demo. All right, so what we're going to do today is I have a really basic to-do list HTML app. So I didn't want to do anything fancy with like Go or Ruby or anything. It's just so we could really see what is required for our container application. So if we take a look at this file, all it is it's actually a little view app that has a little to-do list. You can add things to this. It's static. It doesn't require us to retain state or anything like that. And what we also have is a Docker file. And so this Docker file will, this is probably one of the simplest Docker files you'll ever see. It essentially just tells us what like our base image will be. And it says, hey, take and copy all the files that we have in this directory and put it in our deployment folder. For this base image, I'm using Nginx, and just to give me something to deploy my web app to. So when we have Docker, one of the things we can do is build an image from our source. So this is the first thing we're going to do. So we're going to use the docker build command, and we're going to name our image. I'm just going to name it to do app version 1. And I'm just going to say, build it with everything in this directory. So then you can see it'll pull the Nginx image, copy the files that we asked it to in our Docker file into that directory, and it will build an image. So then the other thing that Docker provides us is it can show us all our images. So if I do Docker images, these are all the little images that I have on my computer right now. So as you can see, this is our to-do app that we made about 23 seconds ago. And then we've also got some Kubernetes thing that services that Docker brought along with it. All right, so now that we've built our Docker image, let's run this. So we're going to run it in detached mode. We're going to put the default 80 port on it. I'm going to name this. That will just let us access it a lot easier when we're doing other Docker commands. And then I'm going to tell it what image to use, and then that's going to be the to-do image v1 from our step up here. So let's run that. Cool. So now this is running. So now what we can do is run Docker PS, which will show us all the Docker processes that are running. I have it to show my Kubernetes as well. You can see it up here. What I'll do is let's clear this so we can get a better look. If we just limit our to-do app, you can see here's our image, here's our name, you can see how long it's been running and what port it's using. And actually, before we go to the site, let's take a quick peek. If we just go to localhost right now, you can see that from our base Nginx image that was in our Docker file, we've got Nginx set up here. And then if I go to our to-do list, here's our cute little web app. We can add to it. It doesn't save it anywhere because, yeah, just a little plain JavaScript app that really doesn't do much. So that's cool. Well, what else can we do with these containers? One of the things we can do is check the logs on it. So especially with Scalyr and logging is important. This app really isn't going to log very much, but we can take a look at what happens. So you can see when I run logs on the to-do app, it'll show me whatever the latest logs are. We can also tail the logs. And then as you can see, every time I hit this, the Nginx is printing out my get on the HTML page. Okay, so let's cancel out of there. So we've got an app, we've got a Docker image, we've got it deployed. That's awesome. What else can we do with this? One of the things we can do is restart things. So as we did before, if we just look at our app right now, it's been up for about 2 minutes. We can restart this. And it will restart it very quickly for us. Oops, and it'll restart it again because I didn't click twice. And you can see, hey, we've had this 2 minutes, but it's actually only been up for about 1 second. So you can kind of see if things have like restarted themselves or if someone else has restarted it. The other cool thing about Dockers and container in general is that we can execute different commands on the container. So one super helpful thing, especially when you're debugging some issues, is being able to actually execute a shell into the container itself. So let's do that right now. Where's my space? Okay. So right now I'm actually inside the container. If we do an ls, we can see all the directories in here. So let's try and find our HTML file. We know this is all the stuff that came over from Nginx. We don't really know where our stuff is, so I'm just going to find our file for fun. And there it is. Cool. So why don't we modify that file and see what happens. So if we come in here, I'm just going to change something really quick and easy. And not that you would ever actually want to do this in production, but it kind of just shows you some of the power that's available with containers, being able to actually shell into there and look at things a little bit closer. So we updated the file, we saved it, and hey, there it is. Awesome. So let's exit out of there. So we'll do a couple more Docker commands, and then next I'm going to kind of like combine it with the Kubernetes that I have running on my machine so you can see part of that. So first, let's stop our Docker app. And as you can see, our to-do app is no longer running. We still have the image right now. We can also remove the to-do app. Oh, that's one thing I wanted to show you. So we've stopped the to-do app, but it's actually still there. So if we do Docker PS, it doesn't show up. But if we show all with a -a, we can actually see, oh yeah, this app is still running. Plus a few that I was playing around with a little bit earlier. So if we actually want to remove it completely, we would do Docker remove. And this one right here is no longer there. So that's just kind of basics of Docker, how you can create, build, and run and remove images. Let's clear that up. So the other thing, so we've really only looked at like the HTML file and then the really simple Docker file. The other thing we can do is deploy this to Kubernetes. Now there's a couple ways you can do this. You can actually do it using this Docker compose file, or you can do it more the Kubernetes way of using YAML files. And I think Dave's already done some webinars more on that side of things, so we're just going to do it using the Docker compose file as an example. So first, let's take a look at this file. As you can see, I've got some services. I just named it web for some reason. And then our image that we built earlier today, which is our to-do app version 1. We're going to deploy this with 3 replicas. We're expecting a lot of load on this little service, so we're going to get 3 of them. And we're going to set some limits on it. We don't want it to use all our CPUs and memory. And we're going to define the port. So since I already have Kubernetes set up on my machine, what I can do now is just use Docker Compose to, actually, a correction, I'm going to use Docker Stack, which will add it to the Kubernetes stack. So here what we've got is I'm going to deploy our to-do app to the to-do stack, which is going to use this Docker Compose YAML to create the 3 replicas with our CPUs and our memory. And I've also defined that the orchestrators, Kubernetes, when we're using Docker locally, it will default to using Docker Swarm. Okay, so we're going to run that. So now we've added to this stack, and let's make sure our app is still running. It is, and you can see it's a new, the old image without the changed file. So what else can we do with this? Let's take a look at, now that we've used Docker Stack to put this on our Kubernetes orchestration, we can kind of take a look at some of the Kubernetes services and see what they look like. So let's take a look first at, we said we wanted 3, oops. We said we wanted 3 instances, 3 replicas. So when we do a get pods, we'll see 3 of our pods here, and that's based off of this deploy replicas that we have up here. So the other thing we can do when we have pods is we can describe them. So we can take one of these pods and just kind of take a look at it, see what's going on in there. And this will show you like your container ID, your image that we built early on in this, your ports, everything else, and also like the life cycle of what's going on with the app. This is really a simple app, so we're not going to get any errors. But if there were problems starting the app, you would see it down in this section here. We can also get services. So this is our web app right here that we've published. You can also see Kubernetes itself as a service. And you can also do deployment. So the deployment is actually what holds the information on how many replicas we want and how we want to scale. So you can see here we've got a desired replica count of 3. Currently it's got 3. Everything's great. It's been there for 2 minutes. So let's go back and take a look at the pods right now. We've got 3 of these Docker containers running in Kubernetes. What happens if we delete one? Oops. I hope if I gave a name. All right, so we deleted a pod. Let's see what's going on with our pods now. Oh, hey, look, we already got a new one. What it typically does is like whatever pod you delete, it'll go into a terminating state, and then it will start spinning up a new pod for you. And then once the new pod is up and running, the old pod goes away. All right, I think that might be all the demo that I have for this stuff. Let me check my notes real quick. Yeah, that should be it. So again, really the things we covered today is just that we can use Docker and create an image using a Docker file. That you can use like a base image that's kind of available within Docker. You can run commands that will actually build the image in whatever way you need it. And then we kind of went through how you can deploy it, remove it, and then also add it to your Kubernetes. So I think that is it for me. Let's go back to the PowerPoint. Oh, no, I do have one more slide. Awesome. Okay, so next, the other thing I wanted to touch on is monitoring. So one of the things you saw is like the Kubernetes would monitor your images and your containers to make sure they were up. If one went down, it would create another one. One of the things you want to make sure is that you do have good monitoring around your containers though, because Kubernetes does so much for you. You really want to know if something's going wrong and if something keeps getting restarted or terminated for some reason. And probably Dave is going to go into this a lot more, but Scalyr can help you with that by just kind of showing what's going on within the pods itself. The other thing that's important is like the alerting and logging. Like one of the things with the containers is since they spin up, they spin down, they're gone, you really can't access them once they've been lost. you do want to get good logging out of them. So if something does happen, you want to know, like, hey, what's the thing that actually broke them? And, what can we do to fix that in the future? And then, of course, a learning, just so you know that something actually happened that you need to look into. And I think that's it for me. So I'm going to stop sharing and I'm going to send it over to you, Dave.
Thank you, Sylvia. That's great. Let me do a quick share on my screen here, and we'll step you through the rest of it. We do have some questions, Sylvia, so if you want to take a look at those, we'll get to those in just a moment past this. So as we heard from Sylvia, Kubernetes itself adds a lot of infrastructure to your monitoring concerns. Basically, you can consider that Kubernetes adds itself 4 layers of infrastructure to your environment. It adds the orchestration itself. It adds the what are now called worker nodes. I prefer the former name of minions because it was much more fun. Pods and containers before you ever get to the application space itself. And all those levels can add new complexity into your environment. So in short, while things may look simpler, they actually make digging a lot harder. There's a lot of balls up in the air at all times across this. And the orchestration piece in particular is the thing that we have to worry about. As you saw also in the demo, we have some pretty archaic and obscure naming conventions that Kubernetes puts in place around here. And while containers really do change the way that we develop and deploy, we've got to be sure that we keep track of ephemeral containers that are only there for a short period of time. And so we get questions like, is the orchestration itself broken? Did I get what I expected to get? And where did things go? Is really all these questions. And so one of the things that we think is important, also Sylvia mentioned this, is that you actually make sure that you're collecting it at each level. You monitor not only the application, the containers, the orchestrated environment itself, and all of those different levels. So what I'd like to do is very quickly step into a fairly quick demo that shows a Kubernetes environment inside of this. So what you're looking at is a Kubernetes cluster. It's a single cluster with 23 hosts running 59 logs. At this point in time, this cluster and log files accounts for about 640 million log entries inside of there. And it's broken into 2 pieces. One is the naming service, if you will. So you can group things together in a Kubernetes space, putting names together that let you group the services of common things together. So as you can see, I've got several ad services, but I have 3 front ends that are inside of this. Down below, you can see the actual servers that they are running on. So there's an app server environment, there's an image server environment, there's a MySQL environment, a web server environment, all inside of here. And each of these pieces has associated with it both the event side, the metrics pieces, if you will, and alerts. In the Scalyr environment, or actually in any of these environments, everything kind of starts with an alert. And in this case, I'm going to look at pod restarts. And the pod restarts are something that Kubernetes watches for you. If it goes down and Kubernetes expects there to be a certain number, it will restart it for you. But pod restarts, when they happen, tend to be things that are not good. This one is basically saying over a 5-minute period, if you see a warning, reason back off that's greater than 1, send it to me in Slack using a webhook. Don't wait before notifying me. Don't tell me another for 60 minutes because I don't want you to flood me on this. And even if it's fixed, step into it. The Kubernetes itself actually has a lot more things that happen inside of that. So there are Kubernetes events that happen. You can look at them by type. You can look at this pod restarts. You can look at the health check. Are things running the way that you expect them to run inside of this? And in particular, I'm kind of interested in these pod restarts. So let's step into that. Take a look at 2 of these. Note you can add an annotation so you can let other people know what's going on. I can zoom to the selection and I can show the logs. Once I've stepped into the log, just to let you see what the log entry looks like, this is a Kubernetes entry log for the pod. So it's telling you all the different things that happened for that particular item, all the way down to what server IP it is running on. So again, Kubernetes puts things wherever it thinks is appropriate based on the configurations that you set for it. But you can also look at it in the original log, the application space. You can see the other things that are happening around it. In a microservices environment, quite often your errors are caused by things that are happening around your events, not with your events. But I'm really kind of interested in what's going on with these pod restarts. In this case, I'm actually using a pod restart, but I'm looking specifically at the container logs to figure this out. Down here, you'll notice I have a nice little stack trace. And inside that stack trace, it tells me the various things. And I can immediately step directly into the source code at the line where the stack trace occurred. So this gives you a very quick example of why you need to monitor across all of the environments at the same point in time that you're looking at how you monitor across all the environments. So that's the demo piece of this. And with that, I'd like to move to our sort of Q&A. And feel free to enter questions into the Q&A tab. We have a number in there currently. With that, if you're up for it, I probably will have to unmute you again for this. Yep, I will unmute you, Sylvia. And if you've got some insights into these questions, if we do not get to your question, we will send you the email answers directly, and we will make the answers available on our blog later on this week. So, Sylvia, you there? Yep.
Yep.
Cool.
Yeah, so the first one I can answer fairly quickly is the question of, can you containerize large databases? Yes, you can. Because normally what you do is containerize the database application itself, not the data. So you don't need, you know, 100 gig container. You just have application, and then the data is actually stored outside of that. So that's definitely possible. And then the next, there's one question, if the person could kind of elaborate. There's a question that says, in using CaaS, what is an application owner should do from shifting application to application? I'm not really sure what that's asking, but I'd be happy to answer that as well.
And if you're, you know, if it's going to take too long, feel free to just drop us a message and I'll follow up with you directly.
There's another question about what is a Docker stack? Yep, a Docker stack is really just a stack of like services that contain like all the containers and images that you have deployed. So it's really just like a collection of the services that you're putting out there in either like your Docker Swarm or Kubernetes.
So one of them that's in here is, how do you do auto-scaling? Kubernetes does have an auto-scaling capability to basically be able to scale in and out as you want. I would suggest going out and just doing a Kubernetes auto-scaling search. You'll find some really great information out there. Actually, from Kubernetes.io has pretty decent information on that. I'll also follow up and send you a direct pointer to that.
And I think this is a follow-up from the database question. Does that mean that the database would be on-prem? No, it doesn't mean that. You can have a database in the cloud. Like typically when you get something, when you're out on Azure or AWS, what you'll have is some kind of a persistent store where you can put your data or your files or whatever else. And then your database application itself would be containerized. So they're kind of separate things. And you can have it on-prem, but you don't have to.
Yeah, you can definitely build a hybrid cloud model in this, where you can actually have pieces of it that are still on-prem, pieces of it that are in the cloud, and actually you can go multi-cloud and cross over multi-cloud. The difficulty then gets into some interesting challenges around monitoring and making sure everything is working the way you want to, as well as temporal behavior that can fall into place because of differences in bandwidth and transmissions. So you have to be very careful that your models are asynchronous and non-blocking if you're working across multi-clouds and a hybrid cloud model.
Yeah, and definitely with databases, we've had better luck of just having them in the same place, wherever that is, the application and the data.
Us as well. We would agree with that.
Yeah.
There's a final question that also I'm not quite sure on. It says, like, if you have application 1, application 2, can I shift from app 1 to app 2? I'm not quite sure whether you're asking about load balancing, which Kubernetes has support. They can use load balancers inside of a fully orchestrated environment, or if you're asking more like a blue-green deployment, also, which is supportable. So you can both of those cases. If you want to flash back, I gave a pointer to something that Sylvia had mentioned our previous webinar in January, which was into the basics of Kubernetes. Actually has more information on how to work in blue, green, and canary environments, as well as how to do load balancing in an orchestrated environment. So with that, if there are no more questions, I'd like to thank y'all for joining us. We'll be holding another seminar, another webinar with demos next month at the end of April. Sylvia, thank you so much for taking time this morning to enlighten us on this wonderful world of CaaS. Quite informative, and I'm going to go back for those of you who would be interested. Sylvia's also written a really great blog on containers as a service. And I would suggest going and reading that as well. So Sylvia, thanks so much again, and we really appreciate that.
All right, thanks. Thanks for having me.
No problem. And with that, I will turn it over, and we will see you next month. Thank you so much for joining us today, and have a great rest of your day.